let's dive into the session. So when 10 years back, he is the guy who made me interest into this topic, artificial intelligence and machine learning sort of things. Like this is my inspiration for machine learning and artificial intelligence. So that's why you can see this is me here, working with a suit like looks like an Iron Man suit back in 10 years back. Then yeah, so I just want to put this up over there, and this is just want to mention this thing. So what is artificial intelligence, and where all these things comes together, where machine learning uh, uh, come inside the artificial intelligence and deep learning, NLP. So basically, machine learning, deep learning, NLP, which is natural language processing, these all are subsets of artificial intelligence. And you can see in this diagram, machine learning is itself a subset of AI, and deep learning is a subset of machine learning. So deep learning, that's bit more deep, like a bit more advanced than machine learning. And NLP, which means natural language processing, you can see that there's an overlap with the deep learning, machine learning, and it's everything is coming under AI. So natural language processing actually uses all these technique, like deep learning technique, machine learning technique, and some other things as well. So it's all related to the natural language. So now I would like to go with these definitions. What is machine learning by definition? So by Arthur Samuel, he just said in 1959, like, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So what does this exactly mean? So what is the difference from machine learning to a normal Python program? That was actually the topic of our last session. So it's like in traditional program, what we do, it works in a rule-based model. But in machine learning approach, the program will learn itself and from a set of data that we provide, and which gives an output which was not there before. Like
Salman, can I ask something?
Yes, of course, please.
Hello, you're there, and thank you for coming for this lesson.
Yeah, please.
I just want to ask if from 1959, this explanation of machine learning, does it change because we're more progressive now and the technology is more progressive? So the explanation is still the same?
Of course, it's still the same. Actually, what changes in between 1959 to till now is the computing power and the way we handle with the data. So there was a quote somewhere, I don't remember exactly who said that or where it is, like 80% of the internet data that we see today is generated just since last 3-4 years. So the two things that extremely change this field, machine learning, or which gives all these things possible, is computing power and the amount of data. But the definition and all sort of things are the same. So there is no change in the definition actually. And I will show you by, there is something in the end of the slide. So I can just, you can relate, you will get a clear answer for this question by that now. So anyway, good question. So this is by definition, and there are multiple definitions, like somebody typed in a lot of where we can define machine learning. So most of them are correct in a way or other. So we can just go to the engineering definition. So what is the engineering definition of machine learning? A computer program is said to learn from experience E with respect to some task T and some performance measure P. If its performance on T as measured by P improves with the experience E. This is by Tom Mitchell in 1997. So anyone, any guess? Did you understand this? What is this exactly? So okay, I will go with this. So I will explain this further. So it's just a computer program, and why it's going like this? Okay, it's just a computer program, but it learns from the experience E. What is the experience E? The experience E is actually it learns from the data that we are telling the model that or the machine that there are set of data we already have. So when I'm saying data, which means, um, for example, let's take a real estate example. So you want to predict a price of the house in the real estate, and you have some data. What are these data? So this data contains uh, all informations from the number of bedrooms, number of bathrooms, total square feet, so and so. And data also, these things are called the features. And data also contain the information related to the price. This is the previous, data that we already know. So it contain an information
The history,
about.
it's the history of the history of the industry that you want to check, right?
Sorry?
The experience is from the history of the time that your work already on this subject. If you take real estate, for example, so the history of how many building sales in some period, and then you
Yeah,
take
it
the
depends.
data.
It depends upon the problem. Yeah. So if you want to predict the price of houses, that is our problem. So that is the problem we want to solve, and the experience is the features like explaining like number of bedrooms, number of the total square feet of this house, and the region, so and so, which depends the price of the uh, house. So also we have a set of list of price related to these features, which is called as labels. So, and with respect to some task T, so in real estate case, the task is to predict the price of the house and some performance measures P. So performance measures are something uh, related to the machine learning model itself. So for making this program, an AI program, we need to create a machine learning model. And we need to train this model with the data. And we need to tell the model like a child, this, if these are these things, this will be the output. And we want to make sure that did the machine learn it's right or it's wrong. So we want to check that. So that's why we use performance measure, or we will say like metrics for analyzing our model. It is performance on T. So it will again do the performance on T as measured by P improves with the experience E. So like it's basically we create a model and we train the model with a set of data, and then we use another set of we don't there are some other set of data that like we know the features but we don't know the price, which this data is not present in the first set of data. So what we do, we ask the model to predict the price of the house from the new data. So that and we will improve the model by checking the performance measure P. So this is just it will be more clear anyway. So let's go to the next slide. So what do you think, where are these application you see machine learning is applied currently? So right now machine learning can seen everywhere in the sense it's in your pocket. If you took your phone, it's already your phone have this capability of machine learning. A lot of application in your phone is already using machine learning. So we can have a look at those, some of those examples here. So see here. So if you use this Gmail, you have noticed this feature before. Like if you try to type an email like this, it will autocomplete. It will suggest, do you want to go? Like here, I have an extra ticket for Han Solo movie on Saturday. Do you? Then it automatically suggests you want to go. So this is machine learning. And here you can see it is auto suggesting. And sometimes I saw like if I just miss the subject and I just started writing this uh, body, and machine is automatically suggesting me the subject, the best subject. So this is a machine learning application that you can see in the Gmail. And this is a computer vision based application which detected the cars and the object basically using a camera. So this is another example of machine learning in real life. And what you are seeing right now is Amazon Go, which uses machine learning and some other technologies like sensor fusion, um, and some IoT technologies to make Amazon Go. So which is a queue-less grocery store. So you don't need to wait in the queue for paying. There is nobody there to collect cash from you. It's like you can just get inside to this grocery store by just scan a QR code, and you can took whatever you want, and you can just go back, and the whole system together will know that what you took, and it will detect the price from your wallet. So this is another example of Amazon Go. And if you are wondering, this is just a demo or something like it's in real. It's real. This is real in New York. You can see the pictures here. And this is Netflix. And Netflix use machine learning by suggesting personalizing the movies, which based on your previous watch. So here the data is like you already watch some movies or documentaries. So Netflix already know that your interest, and even it's track everything in the sense if you watch a movie and just stop somewhere like you like some part of the movie, and it will suggest those kind of movies to you. For example, if you like fighting kind of movies, and you watch those kind of movie, it will suggest those kind of movies to you. This is a recommendation system working behind this Netflix. And here yeah, this is they are just 75% of what people watch come from recommendation. So they made it everything recommendation based in Netflix. It's highly personalized. And in Airbnb, they are using machine learning for a lot of things. Like it help you, it suggests for the users to choose which is the perfect stay for them, perfect apartments for them to stay. And also it will help the um, host to set the pricing. This is the right pricing for you based on a lot of things like um, season, or based on their room, their facility, so and so. It will keep on suggesting the best price or competing price for them. So you can see everywhere, you can see the machine learning. Literally, there is a meme I just got from internet. It's like Google is just putting machine learning for almost all of their product. So the point is, you can see machine learning everywhere you look around these days. It's you are already using machine learning featured application. uh, Even if you know or you don't know, you are already using all these kind of things. So now, I just want to talk about when to use machine learning. So right now you understand, I believe you understand where are these machine learning applications already used. And now I just want to go through this, when to use a machine learning. So since we are using the traditional programming approach, and when and why you need to use this machine learning. So first point, so you can use machine learning solution. uh, where is my slide? 1 second, sorry, what just happened? Yeah, so you can use a machine learning solution for a problem which need a lot of fine tuning or a lot of rules. So in traditional programming, you can same time you can do this in traditional programming, but if you do that in a traditional programming way, you need to write a lot of lines of code, and a lot of rules need to do this, to make this program works. But in that cases, you can just make use of machine learning if you have enough data, and you can just make use of machine learning and things will get easier. And for the second point, it's complex problems for which using a traditional approach yield no good solution. The best machine learning techniques can perhaps find solution. Yes. So there are some complex problems. So even you cannot think about writing this solve this complex problem using traditional approach. For example, uh, you want to write code for stock market prediction. That is very complex problem. So you cannot think about writing a traditional program for that by setting a rules for every dependent variables. Like for as you know that for a stock value is depend upon a lot of factors, and it will change accordingly. So we cannot actually write rules for those kind of complex problems. So we can use machine learning over there. And fluctuating environments, machine learning system can be adapted new data. Again, stock market is an example here. It's a fluctuating environment, and getting insight about complex problems and large amount of data. Sometimes machine learning can also be used for to get an insight about how complex, not how complex, insight about the complex problems and large amount of the data. For example, let's consider telecom an example. So the kind of data we are getting from telecoms is like signals and uh, stream of signals, and we didn't make any sense of this kind of data, and human cannot make any sense of this kind of data. So we can use machine learning to make patterns or make some sort of predictions using all these kind of data. So that's another way of when you have to use machine learning. Now, what are the different types of machine learning? So there are different types of machine learning. So here today I'm going to discuss about this supervised learning, unsupervised learning, and reinforcement learning, and especially supervised learning and unsupervised learning. There are other categories as well. It is categorized in different ways. So one way of the categorization is based on the way of learning, how machine learn. It's one is supervised learning and unsupervised learning, reinforcement learning. So yeah, supervised learning can be used mainly for this prediction. If you want to predict something, uh, you can use supervised learning techniques for that. And unsupervised learning can be used for getting insights about the patterns, or just form some patterns which was unknown to you before, and you just give some data, and your model will automatically find patterns by by the going through the data, like what, for example, if you purchase something from Amazon, it will give you a recommendation of your, similar products. And even if you buy a laptop, sometimes it will just you know suggest for you to buy a maybe a mouse or keyboard. It's based on other people who already brought these kind of things, and also it's make some patterns based on the data that we are giving to this model. And reinforcement learning is use the action, which means it's mainly help you to, this reinforcement learning is mainly used in the gaming and robotics world to do things works for that. And so again, supervised learning and unsupervised learning can be explained in a different way. Like supervised learning, we have, it's more technical way. So I don't know how you will get it right now when I'm saying all this together, but anyway, let me try. So supervised learning is something you already telling the model that, okay, this is my input model and this is my output. So we say that in machine learning world, we used to call the input as features and output as labels. So we label the data. We are connecting the features and labels together. We are saying, for example, for the real estate prediction, the three bedroom, 2,500 square feet, and three bathroom is the features. So these three are the features. And for this house, the price is, let's say, 100,000 or $500,000. So that are the labels. So we already saying the model that there is a features and there is a labels based on our previous, experience or the data. And we train the model based on that. And then after we get a well-trained model, we use this model to predict the price of the house from a different set of data. So that's how supervised learning works. And unsupervised learning, it mainly used by the deep learning techniques. Unsupervised learning, we don't know the output itself, the labels. So there are some set of problems, like we have a lot of data, but we have to find something out of this data. Maybe we want to make some clusters, some classify this data to some patterns and form some patterns. And even we don't know that how this pattern will look like. And we use unsupervised learning for this kind of problems. So we don't have any label set of data. And reinforcement, like I said, it's mainly used for this uh, robotics purpose. Now, there are two types of supervised learning techniques, which is called classification and regression. So classification is a problem. A problem is when output variable is a category, such as red, blue, or disease, and no disease. It's like the output we are expecting is, for example, or yes or no, something like that. So it's a two category, yes, either yes or no. Or there might be more than two category. There might be 10 categories, 20 categories. But the only thing, we want our model to tell us, okay, if we give this set of features, uh, so in which category it is belonging to. So which is called, this kind of problems is called classification problems. And there is another set of problem is called a regression problem. So a regression problem is when output variable is a real value, such as dollars or weights. It's a the one example we can think about is the real estate price. So when we ask our model to predict the price, it's a regression problem because the model is predicting a number, it's a value. So the price of the house is $100,000, $200,000, or $300,000. But in the classification, it's not predicting a value; it's just predicting which class our data is belonging to, or the features are belonging to. So that's about the regression and classification. And in unsupervised learning, there are two types of techniques, which is called clustering and association. So clustering a problem is where you want to discover the inherent groups in the data. So as I mentioned before, so it's grouping of the customers purchase based on their purchasing behavior. So clustering, we are not labeling the data, we are just giving the features, only the inputs, and the model itself makes some clusters based on this data. And there is association. An association rule learning problem is where you want to discover rules that describe large portion of your data, such as people that buy X also tend to buy Y. The same example I mentioned for this Amazon. So it's coming under the association problem. And here we go, the 7-step approach for machine learning, how we do all these things together. So if you want to make your own machine learning model, how you will do step by step. There is a 7-step machine learning approach. So first thing, we have to collect the data. So before starting anything, any machine learning, we need to have some data, like informations about, data is not just some information. It's a, there should be some, input, and there should be some output. So based on, for example, it depends upon the industry you are working. So the, kind of problem you want to solve, you need to collect your data. So data can be, anywhere from some database to some Excel sheet or CSV files. And then the second step is data preparation. So once you get the data, there will be a lot of noises in the data and a lot of unwanted things in the data. So you need to prepare the data, or the clean your data. So that's a second step. And the third step is choose a model. So now you have the data, you cleaned your data. Now you want to use your data to, in you want to give this data to a model. For that, you need to actually choose a model. You see here it's mentioned choose a model, not create a model, because these models are already there. You can just use this model. Only thing you have to be there, you have to be, is that, uh, there is a model called with a name like this, and this is used for these kind of problems. You don't need to create any model from scratch. There are a lot of libraries that help you to, use these already created models. So you choose the model, right model for your problem. So how you choose your model, it depends upon the data or the problem you are going to solve. So then you train the model. So once you have a model, and then once you have the data and the model, you train the model by giving this input data and the labels. Then you need to evaluate model. So once you train the model, you want to make sure that your model learned well. So there are some performance metrics to know that. You can use these uh, performance metrics to evaluate your model. So that is our fifth step, to evaluate the model. If the model is not performing well, you need to, make it tune. You need to tune. That is called the parameter tuning. So you need to tune in order to get the best result. So there are certain techniques for all these kind of, uh, each blocks. And then finally, the seventh step is you use the model to predict, and you giving some inputs, and you want to get the prediction out of this model. So that is the final step. Now, uh, any doubt before we going forward? Hello. Yeah. Okay, so um, now any questions? If you have any questions, okay. Now I just can, we can go through some of the machine learning application and the kind of techniques used for those kind of applications. So the first one is analyzing images of products on production line to automatically classify them, which is an image classification problem, and which use a technique called CNN. It's an architecture actually. So for analyzing images, so anything related to image come under the group of image classification. So there are certain models, or what we say architecture, for solving these kind of problems. So one of the best one is the CNN, convolutional neural network. So, and then the second is detecting tumors in the brain. So we can solve these kind of problems using semantic segmentation. And again, we use CNN for this. And segments clients based on their purchase. You can design different marketing strategy for different segments. That's coming under the clustering. So it will cluster your clients based on their purchase history, and it comes under the unsupervised learning technique. So there is so now we need to look into this. We need to answer for this question: why should you learn machine learning? So uh, first one, machine learning helps increase your efficiency. So how it is helping you to increase your efficiency? So efficiency of your organization maybe. So for example, you saw what Amazon did for Amazon Go. It reduced the queue by applying machine learning and make everything fast. In just in the grocery, you don't have to wait in the queue for after purchasing things in your grocery. That's how it's machine learning helps increase your efficiency. And the second one is you can understand your customers better. So again, we already gone through this. By applying machine learning, you can segment your customers, and you can know better about your customers. Also, you can personalize your marketing campaigns. So once you know your customers, you can also use machine learning to personalize your marketing campaigns for each customer. So you don't have to depend upon the traditional programming approach for writing rules. For that, the machine learning will automatically do it for you. And the fourth one is machine learning recommends products to your customers. So the one we saw for the Amazon, machine learning can recommend products to your customers. And machine learning helps to detect fraud. So this is like for fraud detection in payment transaction, we use machine learning. Machine learning brings in better career opportunities. Of course, everyone's know that nowadays machine learning job market is booming, and machine learning brings machine learning engineers can make a lot of money. These days machine learning engineers are paid really very well. Machine learning jobs on the rise. So these are the some of the reason you need to learn machine learning. So I just want to show before that I want to know any questions. Do you have any questions?
Yes, I got one.
Yeah.
I want to ask if the technology that use cookies in websites, is it using
machine learning?
Yes, thank you.
Okay, so cookies, uh, I don't think for using cookies you don't need a machine learning uh, techniques actually. But by using cookies, they might be collecting your data, a lot of data. So they can use that data for some machine learning purpose. That depends upon the problem. Like that depends upon the problem they want to solve. So yeah,
Okay,
I
thank
think
you.
that
Yeah, it's answering the question.
Yeah. Yeah.
We
Yeah, you're right, David.
We also have
Yeah.
another question, a few other questions. I could read them out.
Yes, yes.
Just a second, my chat box disappeared. Okay, there it is. We have a question from Kavya, who's asking, how is CNN used in ML, and what is the difference of it in deep learning?
Actually, as you remember from the first slide, this one. See, deep learning is a subset of machine learning itself. So when I mentioned CNN, it's part of deep learning technique actually. And if you want me to explain this working of CNN, I think we don't have enough time for that now, because especially CNN is a complicated, comparing to other models. For example, there are reinforcement, sorry, not random forest models based on decision trees. So that is one of a simple model that can be explained maybe within a few minutes or seconds. So but when you come to CNN, it's a bit more complicated than the random forest or decision tree based model. So CNN actually there is a lot of techniques to you need to understand before, like how CNN really works. Like there is something called max pooling. So I need to explain each and every cell of that first. So maybe in a later on session I can do that. Yeah. So it's again.
But
it's
in short, CNN works like a human eye, and whatever the human eye, each cone in the rod cell perceives. So instead of looking at the letter A, we just look at maybe the top kink on top of the A, or maybe at the bottom we look at the small line that ends on the A, and maybe on the faces we just take a look at some edges and lines. And as you had mentioned, by using max pooling is nothing but you take what the small subsection that you see, and you make a sense, okay, this may be the corner of some object. So in short, CNN is along those lines.
Yeah. So Kavya, is that make sense for you?
Yes, obviously. I know it cannot be explained in a very short time. I was just curious, like when you gave an example on under the unsupervised learning, with CNN, I was just wondering, like, in which use cases do you use this model? Like you said, example of random forest model for regression techniques.
Yeah.
Like in which all use cases do you use the CNN models?
It's CNN we mainly use for image. Let's say if you want to predict just taking a photos of some objects, and you want to predict whether you want to identify which object is that. For example, it's a dog, cat, or something like that. So we can use CNN for that.
Sure, thank you.
Welcome. So any more questions? So initially, when I thought about going much deeper technical for this session, but then I got some feedback from some people, like people who are attending this course may or may not know into this field. That's why I just made it very light. So it will be for the coming session, it will be really nice if we if you guys are joining for any of this session. Let's mention about how well your knowledge in this topic. So based on that, I can go for the sessions. So, and I just want to know whether this will helps, like did this session helps you?
Is there anything anyone would have liked to understand more about? Was the depth of the content what you guys are looking for? Did you want us to go a little bit deeper, or was this the right level? Feel free to write it in the chat box. Good,
yes, of course,
deeper,
please,
less deep.
please.
Go ahead.
So that's exactly we need.
Mm-hmm.
So based on your deep would be
David is
nice.
saying
Okay,
deeper
of
would have
course.
been nice. Yeah.
Of course. Okay.
Hi.
Deeper. Fine. Yeah. Hi,
Hi.
David. Yes. Hi.
Maybe my addition would be, yes, it would have been nice if it were deeper. The best application, I think, if we had more illustrations for the different types of machine learning, as well as just more examples, even if it's from movie selection for classification and something like that. I think the illustrations would have made the message become much clearer, but it was really nice and insightful. Yeah.
Nice, good point. Thank you for sharing.
Thank you for the feedback. Yeah.
And
so
before we go, we go, everyone, if you'll notice that I wrote on the chat, just feel free to, it'll be great if you just open the chat right now. Basically, I shared a link of AstroLabs Academy where we give a lot of in-depth sessions, whether they're workshops. I'm going to put it over here. Just feel free to open it right now and then look at it later on. But we do give a lot of courses on like coding. We have data science boot camps as well. We dig much deeper into machine learning, and they're not 1 hour, but they run for much longer than that, up to 8 hours, and they're like full-blown courses that give you the depth that you're looking for. So, for example, if that's what you are looking for, please go ahead and press the link over here, and you feel free to just skim through the courses and sign up. And feel free to reach out to me if anyone has any questions. It's just my name, Nadine, at astrolabs.com. Okay, everyone. So thanks again for attending this session. We have one more last thing from Kavya.
Yeah. Okay. Just I also want to add something before you. Okay. Yeah. What is the question anyway? First.
Kavya, very helpful. Sure, we need more sessions on how to choose a model, learn each model in detail, something like that. More deep dive into the topics.
Of course, we can do that. And also, if there is one link. So there is I can share that link in here. I don't know why it's happening. Like my presentation is going somewhere. I will share this link. It's a Instagram profile which dedicated for the AI ML. So I'm just sharing this link in here in the chat. So you can, if you want, you can go through there, and it will be, so there are some helpful content for you. And yeah, that's it. And also, if you want to reach me, you can find me here. reach.at/Salman if you have any kind of questions, or also if you need so I'm just providing a 2-hour consultation for organization. If you have any need of this AI machine learning related problem, for people who are attending this course, I'm just giving you 2-hour free consultation. So if you have if you want to discuss with any of the problem in your organization or something like that, for your side project, you can reach me at, and we can talk about that also.
Yep, I'm just sending them again to everyone. It seems that they didn't get the link. So over here is his Instagram, and then over here is reach@Salman, which is over here. And then I'm gonna put the sessions again for those interested in signing up for courses. It'd be great if you guys just open them up now and then read them later before the session closes. So I just sent you all three links. So Instagram for Salman, his Reach URL, and also the link for our Open Academy sessions that are relevant to this as well. So thank you, everyone. Thank you, Salman, and hope to see you soon in another session. Bye. Take care, everyone.
Bye-bye.